All right, hello internet. Welcome to my channel once again. Here on this video, I'm gonna show you a hands-on hands-on lab or HOL that is being offered by VMware. And on this lab, we're gonna talk about VMware NSX for and vSphere advanced topics. So I actually had like a training before with VMware NSX, but that was a year ago. So I really don't remember what I did there on that training because I'm not part of any project that has NSX. But on this lab, just gonna review whatever features that is in NSX. I understand the high level of what NSX is because before there's actually a couple of customer discussion where software defined data center, right? We're talking about NSX. If that can be integrated with Cisco ACI or application centric infrastructure. On the previous version, it's not yet supported, but now I saw that there has been an integration, but I haven't really went or took a deep dive to understand how the integration works. But yeah, they said on a certain version of ACI is already supported. Okay. But here, I'd just like you to come with me and let's do the lab for VMware NSX. So at least, right, you're just gonna watch the video. You don't have to do it yourself, but you want to, you need to register with your own email address, right? I think if you have like you can use our personal email and log in, right? But in my account, I'm using my partner access account because my company is a partner of VMware. All right. So on the right side, right, you'll see here like 382 pages, but let's see how far can we can go. But we're gonna give it a try. But this is the lab portion where we're just gonna read on the lab and do it here on the left side, right? Okay, so there. So lab guidance. So I'm just gonna move forward on the pages that are not really relevant because I'm really familiar with the interface already. So let's just click next. All right. Okay, diagram, act online keyboard. Okay, so I'm just gonna click on next. So when you're studying this, right? For me, if you're starting with VMware, it's okay to look at the concepts and understand, what vSphere is, what are the features of VMware. It's okay if that's where you learn faster. But for me, even though I have not, I don't understand the whole I don't have that vocabulary of all the features in VMware. I try to at least do some labs on a certain technology for me to understand, right? And that's where you're gonna encounter all of this um, terms, VMware terms that so at least you're gonna be able to connect that back to the text or the textbooks or to the white papers that VMware has. So I try to do the lab first, then connect it back to the reading materials. Let's move on. All right, so module one, distributed networking. So what I understand with distributed networking, right? So instead of, so of course, if you have like one ESXi environment, you can do networking, but it's just on that environment. It's just like one VLAN, right? One endpoint you can communicate to the other endpoint, but it's just on that same, I don't know, chassis, right? Where you have your own port groups on that specific chassis or ESXi where these two endpoints or VMs can communicate to. But with the vSphere or with distributed networking, you can actually talk to each other even though the endpoints are on two different environments. When I say environments, maybe two different chassis. I don't know yet actually if I'm saying it correctly, but that's what I understand. Maybe they have like a layer three network in between, but they can still talk to each other. Let's see, right? What it is. As I've said, I'm not an expert in VMware, but I'm willing to learn. I'm willing to explore what this is. Next. So distributed networking module, we review existing configuration NSX, breadth, ESXi host, VTEP configuration. VTEP is just like an endpoint or virtual channel endpoint. Segment ID pool, I don't know, maybe a VXLAN ID, transport zone. Create the logical switch, then attach two VMs. Okay, I get that. Test connectivity between two VMs on the same logical switch. review the configuration of a pre-deployed distributed logical router, and add a new logical switch to the distributed logical router. Okay, I get that. Understand this, right? It's just like how you actually attach a VM to a port group, right? And you in the ACI world, that's gonna be you have integration working. That's gonna be an endpoint group or an EPG in ACI terms. Okay, logical switching. Okay, confirm configuration, logical network. Okay, so I hope we have a lab here. Okay, there you go. So open Chrome. Okay, let's just follow it. Then which one do we open? Region A and VCSA01 client. There. What's the password? See? Windows session only. Okay, you don't need to put anything here. Just use the credentials that they use for Windows. Then log in. Okay. All right. So we're now on the web web view of a vSphere. So let's go to network. Then click networking and security. Okay. All right. Okay. So current topology. What does this mean? So VDS is a virtual or distributed virtual switch. That's what it means. And you have the ESXi hosts here. So these are just servers, right? Call it, I don't know, we call them ESXi. um, you have the VMs, okay, vCenter server, NSX manager, controller, NSX edge. Okay. The DevOps diagram displays the current lab topology. The cluster region A01, COM01. Where is it? There's the cluster, this one, right? Which includes ESXi01A, this one, and ESXi02. Host all the applications virtual machines. Cluster region 01 management edge 01 here, which includes ESX03 and 04. These are the management, okay? So this is where the VMs are, or maybe user VMs, and this is where all of this are installed on this ESX hosts. Okay, and all the virtual edge. All of the SXI hosts are attached to. Okay, so they're connected to this VDS, or to let's look at it as a switch within the virtual environment, VDS comp. You also notice that there is an additional cluster called region A01 NSX-T edge. Where is it? Additional cluster called region A01 NSX-T edge we use for migration coordinator. Is it this one? It can be ignored at this time. Okay. All right, so you have a VDS, just like a switch. You have host, ESXi host. These two guys will have the user VMs, and these two guys will have these, right? The vCenter server, NSX manager, controller cluster, and the NSX edges. Okay. All right, make this smaller. Let's see. So view the deployed components. So click installation upgrade. It is actually very intuitive, right? So this lab is good because it shows you which should be clicked first, second, and third. Okay, so let's click that and host preparation. You got here the region, okay, comp. So this is the cluster for the VMs. So click that. So you will see that the network virtualization components. Okay, what is that? So when you click on this one, okay, NSX version. And these are the two ESX hosts running on this version, I think. Okay. All right. Power VXLAN functions are configured and enabled on each cluster after the installation of the network virtualization components. The port security module provides the VXLAN function. Port security module, okay, provides the VXLAN function, while the distributed routing module is enabled once the NSX Edge Logical Router controlled VM is configured. Okay, and you will notice that the NSX version that is installed is NSX vSphere 6.4.6. Yeah, this one, 6.4.6. Okay, now let's view the VTAP configuration. Where is it? Maybe this one. Right. In the list view, actually, let's click this. Okay, the list VXLAN configuration can be broken down into three components or three important steps. Configure the VXLAN or VTAP on each point or host. Configure the segment ID. Host. Segment ID. Configure the transport zone to define the span of the logical network. So as shown in the diagram, the host has been configured with VXLAN tunnel endpoint interfaces. The environment use 192.130.0/24. So this one is inside the subnet. I don't, I haven't appreciated it. Oh, maybe we have to click on this one. Ah, there you go. Yeah. VLAN, MTU, build order, view details. Such as okay. Anyway, yep. Let's move on. So segment ID and multicast group address configuration. So one of the key challenges in VXLAN deployments in the past was that the multicast protocol support was required from physical network devices. This challenge is addressed in the NSX platform by providing a controller-based VXLAN implementation, which removes the need to configure multicast in the physical network. Okay, NSX provides three options for broadcast, so bump traffic, right? Broadcast unknown and multicast. Multicast, unicast, and hybrid. This option is defined globally. The three modes of replication available in an NSX. Okay, so there are three modes of replication available in NSX. First is multicast, where the NSX relies on the native L2, L3 multicast capability of the physical network to ensure VXLAN encapsulated bump traffic is sent to all VTEPs. All right, so in unicast, the control plane is handled by the NSX controller, leveraging head-end replication. Right, that's the key term. And no multicast IP addresses or special configuration are required when using this replication method. Third is hybrid, so an optimized unicast mode. Okay, optimized unicast mode. It offloads local traffic replication to the physical network using L2 multicast. Okay, this requires IGMP snooping on the local switch, but does not require a multicast routing protocol such as SPIM. All right, hybrid mode is recommended for large-scale NSX deployment. Okay, so we have a really good um, design concept in here. Right, so if you know how multicast work, IGMP snooping work, right? You should be able to at least connect what this guy is talking about in here, right? Let's move on. Now let's view the segment ID. Go to local network settings. Okay, so this is the segment ID pool. Okay, so I think in VXLAN, if you know VXLAN in Cisco, right? I remember there's this kind of ID, but it's a VNet. Yeah, I think it's a VXLAN network ID. I forgot, but it's a VNet that has the same, convention, like on a thousand value, like this one. Okay, so this is the segment ID pool. So note that the segment ID pool is assigned to the environment. As logical switches are created in the NSX, the next unused segment ID is allocated and assigned to each new logical switch. Okay, so it seems that, am I understanding this right? So each of the logical switch that we create in NSX, it will have it will be configured or assigned with the segment ID coming from the segment ID pool. Right? It's just like an ID, right? For the system to know, like maybe an endpoint is connected to this switch or a V switch, then this V switch will have this particular segment ID. So if somebody has to send the traffic to that endpoint, it will use the segment ID, let's say 5000, to be able to reach that endpoint by sending to this V switch with that specific segment ID. I think that's what it means. Now note that the multicast addresses field is blank. Okay. As previously mentioned, this is because the default mode of the lab environment is unicast and therefore has no multicast requirements. Okay. So let's view the transport zone. So where is it? This one, transport zone. Should I click? Click. That happens next. And we click edit. All right. Should we do next? Okay. So replication mode is unicast. Okay. Okay. So all of this modes, right? It's just the we just put. I think it's in here, right? Because this describes how we manage the endpoints from the control plane. Like, let's say when we say about unicast, right? If an endpoint is connected to the network or to a switch, then that switch will tell everybody, or maybe the controller, I don't know yet, that oh, this endpoint is connected to me, right? So it's either we send it by unicast, or maybe let the other switches know about this endpoint using multicast. I think that's what it means. Okay. It's just a matter of ensuring that an endpoint, the fabric knows where an endpoint is, and this is how we tell the others that hey, this endpoint is at my back or is directly connected to me. Okay, let's just cancel it. No need to do any change. Let's go to connect clusters here. Then, so what does it show? Connect cluster. These are the two clusters, right? This is for the endpoint or to the VMs, and this is for the management. And server clusters are members of the transport zone. Observe that all clusters are members transports indicated with a checkbox, right? Okay. To return to the transport zone, click cancel to return to transport zone. Yes, okay. We'll now create the NSX logical switch. The NSX logical switch defines a logical broadcast domain or network segment to which an application or virtual machine can be logically connected. An NSX, okay, switch can provide a layer 2 broadcast domain similar to a VLAN, but without a physical network configuration typically associated with the VLAN. Okay, this is where the networking comes in. So I'm going to go to logical switch. So I think these are the logical switches that are currently configured. So notice that there are a number of logical switches that are already defined in this lab. And this has been pre-populated and will assist in completing the various modules provided. The next step will be to create a new logical switch. Once the switch was created, we'll migrate existing VMs to the newly created network. Okay, so click add. So we click add. Then, okay, let's add the name web dash ls. Transport zone, okay, TZ, unicast, IP discovery enabled, and we click add. Okay, so we're just adding a new logical switch here on this step named web logical switch. That's why it's saying ls. So here, enabling IP discovery, okay, activates ARP or address resolution protocol suppression. ARP is used to determine the destination MAC to address a MAC address from an IP address by means of sending a broadcast layer 2 segment. If an ESXi host with the NSX virtual switch receives an ARP traffic from the VM, the host sends the request to the NSX controller, which holds the ARP table. Okay. If the NSX controller has information of its ARP table, it is returned to the host, which in return responds to the VM. Okay. So now we attach web01A, 02A to the newly created logical switch. So we click on the radio button here and click add VM, right? So what we're doing here, right? It's just like physically adding an endpoint or a server going to a switch, which we call as web ls. So we just add it, add VM. Then, all right, so it's saying search for those VMs with a web. Then choose web 01A 02A corp local. You click right and click next. Okay. So select the virtual machine VNIC. Okay. So the virtual machines, right? How is it going to be able to connect to the switch? Or let's say you have like a physical server. How do you connect to a switch? You have to have a NIC or a network interface card. That's for the physical world. But if you're on the virtual environment world, right? A virtual machine is also a server, but how does it connect to the virtual switch? You have to use a VNIC, right? That's a virtual network interface card, and you have to connect it to the logical switch that we created earlier. Okay, so just click this one. Okay, so it seems that both of these VMs only have one VNIC, and we can map it back to or connect it to the web LS or to the logical switch. Okay, once done, verified, and finish. Okay, so just to describe what we did, right? Let me draw it. So what we did, we have a logical switch, the web LS, right? And you have two VMs here, two VMs. You have a VNIC here, then you attach it to the port to the web LS or to the logical switch. So that's what we did in here. Okay. So next, so right there. So the topology after web LS is created and web VMs are connected. Okay, yeah, that's it, right? Here. So you have VM1, VM2 connected to the virtual switch or to the logical switch, web LS. So let's test the connectivity between web 01A and web 02A. Okay, so as you will notice, right, if we go back, so this is just like putting this VM and this VM on the same VLAN or on the same network, because this logical switch is being represented like a VLAN in the non-virtual world, or on the how do we say it, on the physical switch world, right? So by default, this guy should be able to talk to each other, right? Even though you don't put any gateway here, just L2. These two guys should still be able to communicate to each other. So in the next step, we're going to verify that. Okay. So go to menu, then host and clusters. Look for this cluster is a COM01 and web 01A here. Okay. I think it's just launch web console. Yep. So just use the web console here. So root and Vmware 1 exclamation point. There you go. So we're logged into one of the VMs, right? Then we just ping the other VM, and it seems that DNS is configured properly, so we can just ping the host name. So ping -C to web 02A. So -C, I think, is count, right? So in Linux, so ping -C, two pings only going to web 02A, and done. Okay, so it's yeah, it's pingable, right? So it's saying here, if you see a dupe packet, this is due to the nature of the VMware's nested lab environment, but this will not happen in a production environment. But I didn't see it here, so that's fine. All right, that's distributed switching or logical switching, right? Now let's talk about DLR or distributed routing. So DLR is a virtual appliance that contains the routing control plane while distributing the data plane in kernel modules to each hypervisor host. The DLR control plane function relies on the NSX controller cluster, okay, to push routing updates to the kernel module. This allows for optimized east-west routing within each local hypervisor removing the need to hairpin traffic through a single point on the network. So you will first explore the configuration of distributed routing in order to see the benefits of performing routing at the kernel level. So how do I interpret this, right? If, well, of course, let's think from the perspective of a network guy. So let's say you have like two endpoints here, same VLAN, no problem, right? You have two endpoints here, same VLAN, no problem. But if they are on two different VLAN, routing should be enabled, right? Let's say this is 10.x.x, this is 12.x.x. By default, they're not going to be able to talk to each other because they're on two different VLANs. So you have to enable routing, right, on this part. Okay, so well, so you'll be able to reach the other subnet or segment. So I think that's what we're doing here, distributed routing. Let's see. Okay, so here we have Web01, Web02 on the same logical switch or the same VLAN, right? The green line. And we have another VM here that is on the red line. So if you're living in Singapore, you know the train there has colors, right? So if you want to move to the other train, you have to walk. But no, but this one is different. I mean, you need to be connected to a router. So this guy can talk to the VM on the green line. The same thing with this guy, the DB. It has a link to going to the distributed logical router. Okay, so all of them should have that, so the router can do the routing function between these two VMs that are sitting on three different networks, right? These are three different networks. By default, they're not going to be able to talk to each other, else unless you're on the same, sitting on the same logical switch. Okay, so let's move on. Um, okay, so Chrome again. Okay, we're logged in. Let's go back to networking and security. Okay, so we go to the NSX edges. Mm, okay, maybe let's try to check how it looks like now. So VMware NSX diagram. So we have a good view on how it works. Let's see if we can find one. NSX lab. Yeah, so this is how you study, right? You don't have to be ready 100%. At least try it and search the internet for some references. Maybe you'll get a good view on how it works. Management compute. I don't understand this one. It's just a lot of information. What about this? Okay. Firewall, virtual, load balancing. Okay, nice. Okay, so this is it. So let's try to interpret the design of NSX. So you have a physical network. Of course, you have all the cables here and the endpoints. I mean the SXI host connected to each other. On top of that, the data plane. This is where the distributed services, like the logical switching, of course, okay, connected to the NSX edge. On the control plane, are you going to know where an endpoint is? You need the control plane, right? So you have the logical router, and you will have the NSX controller. Then the management plane, well, what does it mean? Manage logical network control planes. Okay. So vCenter server and the NSX manager and the cloud. Okay, got it. So let's move back to the lab. Navigate to the distributed logical router, NSX Edge. Oh, okay. So the NSX Edge is our DLR, I think. Yeah, Edge number 6, or the distributed logical router. The Edge. Okay, makes sense. Then we navigate to the interfaces page for DLR01. How do we do that? Uh, hmm, maybe click this. Let's see. Oh yeah, that's it, right? So when you click that, go to configure and go to interface. Okay. What does it say? What does it tell us? Okay, it has the NIC number connected to the server. It's connected. Okay. So there are three logical switches. So these are the logical switches. Okay. So these are the three. So think of this one as VLANs, right? That are connected to the router, just like router on a stick, right? So I'm just trying to connect the virtual world to the physical world in networking. So think of this guy, DLR01 is just a router, right? And you have three different VLANs connected to it. So let's say you have like one big pipe in here connected to the switch, right? And you have .1 Q trunk in here configured with VLANs DC transit. Maybe this is 10, 15, 20, something like that. But these are just VLANs or these are logical switch, right? Because eventually these VLANs are configured on the switch. And if you have two endpoints on the same VLAN or on the same logical switch, they're going to be able to talk to each other. But in terms of the gateway, um, think of it as the gateway here on the .1Q interface, right? Or so this is the router on a stick, right? So the gateway is actually in here, right? So for this guys to talk to each other, it has to go to the router. Then the router will route it back because it knows where the other subnets are. Okay? Where? So three logical switches have already been connected. And here you can see VNIC number and name of the logical switch along with the type, internal and uplink. So what's the difference? I don't know yet. The IP address configured on each logical switch is associated with the default gateway for that logical switch, and then you can see what construct it is connected to. In this section, we're going to focus on the status of the DBLS, this one, and AppLS, and create a third interface called WebLS. Okay, let's do that. So add. So in the name, let's put the name WebLS. Click internal. What's the difference of internal and uplink? Let's see. And maybe later. Then click on the pencil icon to edit the field. What's next? Under the logical switch, radio button. Web logical switch, okay. All right. Should be connected. Add. Configure the subnet. So add a subnet. 72.16.10.1. Okay, so it's just like adding the IP address on the. So if you have a router on a stick, right? On that router, you put an IP address on the sub interface. Then you put a tag, right? That's how we do it in Cisco. I think this is just how it looks like. So this is the IP address of the sub interface with a VLAN tag. Then 24. Okay. Okay. There. Internal connected. Okay, good. Okay, I got it. So we have a sub interface configured on the router. So this connected to this is the setting for you to map that particular sub interface to the VLAN or to the logical switch, the web LS. Okay, and you put the IP address in here, right? Makes sense. Add it. Okay, let's see. Okay, it's taking some time. All right, that's good. It's now configured, right? So this is the on this DLR on this router, we configured another sub interface, right? If you're talking from networking field and connected to this logical switch or to this VLAN, web LS, right? Then now you will now see the logical switch and DLR01. Awesome. Okay. Let's go to the menu, then hosts and clusters. What should we do? Go to Web018 Corp local. Oh, okay. Maybe we're gonna ping endpoints on the other VLANs, like the application and DB, right? Because remember, the web VMs are on the same logical switch or on the same subnet, same VLAN, but the others are not, like the application and the database VMs. So we go here. Let's see if that's what we're trying to do. Okay. Okay. Earlier, what's configured already, right, is this blue one. The blue, which is from the DB, it's already connected to the DLR. And the red one, and this one is not yet there, but the last activity that we did is to configure this green line from the logical switch going to the DLR. And this DLR is the NSX edge. Okay, so remember that. That's how we connect the concept or, this function. All right. So again, right, guys, again, I haven't done this lab, I think, but I think based on what I understand in traditional networking, I was able to at least connect the principles, and I think I'm correct. This is just a sub interface on a router or a router on a stick. All right, okay. Let's try that. So, all right. Okay, so yeah, we're gonna ping that. Okay, so ping the app VM, ping and count to app 01A. Can we actually ping? Yes, we can. Right, so you'll notice that it's actually sitting on a different subnet. Right, let's check how to verify the IP. So as you will notice, right, the web VM, this is sitting on this subnet 172.16.10.11 /24, and we're able to ping the app VM, which is sitting on 172.16.20.11. So this is 20 and this is 10. So two different subnets or networks, and they're now able to talk to each other because of the DLR or the distributed logical router. Let's try to ping the other one, which is the DB or database 01A. Yeah, we're also able to ping. And this time, this is the IP of the DB 172.16.30.11. Okay, makes sense. All right, that's the end of module number 1. Okay, so here it's fun that we understand how the logical switch works, just like a VLAN, and we have a distributed logical router, which is actually a router. The function is just like a router. All right, good. Now let's move on to the next module. It's module 1. Okay, let's go to the edge services. The NSX Edge Services Gateway is a VM form factor appliance that provides routing and other advanced network services. Okay, so this is actually a long one, so I'm just gonna cut the first module. Then just watch out for the next one, and I'm gonna talk about the module 2 Edge services. All right, thank you very much for watching module 1 of our VMware NSX vSphere Advanced Topics. Thank you.